Alright, so here we are again, another problem, and I figure I'll just kind of go one into another here. There are, I guess, other things I could be doing, but I don't know. We'll just take a look at this one, see where it goes. Yeah, what do I have to say about other things? We'll just look at another problem, get my mind working on that. So, validate IP address number 468. Excuse me. Given a string IP, return IPv4 if IP is a valid IPv4 address, IPv6 if IP is a valid IPv6 address, or neither if IP is not a correct IP of any type. Valid IPv4 address is an IP in the form x1, x2, x3, x4, where 0, each x of I is between 0 and 255 inclusive, and x of 1 cannot contain the leading zeros. For example, 192 are valid, but 192, 168.01.1, or while these other ones are not valid. Okay. Yeah, well, this one, and this one are not valid. Where you don't have you have a leading 0 in this spot. You have two zeros, also leading 0 in this spot, and an @ symbol randomly in this spot. Or missing a dot. Okay. So interesting. I don't know exactly how we're going to validate this, but yeah, this is a good question. This is like, I don't want to say it's an easy question. It's not really an easy question. It's easy in the sense that it's very clear what we're supposed to do. It's not easy in the sense of like, well, how exactly do we achieve this, and how do we do it in a way that's like quick and straightforward and simple. A valid IPv6 address is an IP in the form similar to IPv4, but has 8 values instead of 4, and they're separated by semicolons, where each value is between 1 and 4 inclusive. These are hexadecimal strings, or excuse me, not the value, the length is between the string is between 1 and 4, and the length of the string is between 1 and 4 inclusive, and each are hexadecimal strings, which can contain digits, lowercase English letters, and uppercase English letters. Okay, so the letters in the hexadecimal string can be lowercase or uppercase. Okay, that's interesting, but yeah, the letters could be only A through F. Leading zeros are allowed in X of I. Oh, this is X of I. I thought this is X of 1, so X of I. Okay, leading zeros are allowed in X of I. Oh, that's interesting. So you can have leading zeros. All right, fair enough. You can basically encode the conditions here, I guess. Yeah. Interesting. So these have to be digits, and the first digit can't be a 0 unless that's the only digit. Basically, it's how you check the leading zeros. So basically, each of these conditions, as described, you just translate them to different conditions to check for. Now, what's interesting about this is actually not totally correct. IPv6 can have you could actually be missing these sections, in which case you'd have a double colon, and you can actually get rid of a whole chunk and just have 2 double colons, which it looks like we're not going to be validating those IPv6 addresses. And neither. So we check if it's one, check the first one, check the second one, and then letters, digits, and characters. Oh. Okay, so IP is not going to have an @ symbol in there anywhere. the input. So this actually isn't something that we have to worry about, but okay. All right, sure. So fair enough. Let's do this then. We'll do some parsing. So we'll do IPv4 validation with IPv4 validate, and we'll do and IPv6 validate. Right, and both of these will take the string as an input. So IPv4, first we're going to parse. So I'll have another subroutine. This is interesting. Yeah, okay. Use S. We'll actually use S for each of these. I don't really like this variable. Actually, we could just use S for all of them. Really don't need to use IP, it's just some string. All right, so parse, what's that going to look like? That's going to be, have delimiters. We're not going to write any templated code to do, what do they call it? We're going to actually write the whole program, I guess not the whole program, but we're going to write a like somewhat custom function here, but I saw there's a split command that Python has. I saw a split command by Bjorn Stroustrup, and he wrote it using template programming, and I thought that was interesting. But we're not going to do that. I'm not going to do that. I think it was template programming. What did he use? He used, yeah, yes. It wasn't class templating. It was it? Wait. I think he did use some kind of a template. What did he do? All right, we gotta look it up now. Hold on. There it is. Is it this one? No. Yeah, I think this is it. Is it this one? I don't know where it was. No, man, where'd it go? I couldn't find it. I found it a long time ago, but it was like it was like an interview type of thing. I learned recently that Morgan Stanley is like basically the largest bank on the planet. So it's kind of interesting that he's a fellow, technical fellow, managing director over there. Very interesting. There was or is a particular never mind. I can't find it. Basically, he never mind. All right, forget it. He wrote some code for splitting a string on a delimiter, and I thought it was really interesting. But he used the template programming for something, but I forget now what he did with it. There was something he used it for. I thought it was really interesting. I don't remember now. But anyway, we're gonna write our own. So just to write a routine. So what we're gonna say is for each character. So we're gonna have standard string current. Do it this way. And we're gonna go character by character. And we're gonna say if C is not equal to the delimiter, or just character delimiter, plus equals C. Otherwise, if it is the delimiter, then we're going to set this to the empty string, and we're going to push back a vector of strings. I'm going to return that vector of strings. And we actually could probably make this parse a little more general. Doesn't need to be just for this function only. Oops, yeah, that's fine, that works too. So, yeah, we are going to have this string, we have ret, we see a character that's not the delimiter, then we're going to append it to ret, or to current. If we see the delimiter, then we set current to the empty string, and we don't append anything to current, and basically we just skip the delimiter, and yeah. Oh, I understand now why if you this must be how the Python split was written, because if you Python split on like 3 dots and the delimiter is a dot, right? It'll actually give you multiple. Actually, there's one more thing we're missing. A couple things are missing here. That split will actually give you multiple strings. Like it'll give you the string to the left, and then and it's an empty string, and then an empty string between each of the dots, and then a final empty string at the end. Excuse me, which is exactly what this code is going to do too. Right, so you get the first delimiter, you get pushback current, second delimiter, third delimiter, and then finally at the end there's an extra one where there's no delimiter. That's pretty interesting. So yeah, our code's going to do the same thing. That must be why the Python code does that. Interesting. So anyway, so we can parse our string now. We can say, I don't know, parsed. In which case we're going to take this guy. Parse of S and the delimiter is going to be a dot. And then now we can operate on each of these strings. So what do we want to do? This is going to return a Boolean. And we can say return, by the way, this has, so we just have a, whoops, that's not what I wanted. Whoops. So I have a default at neither. So if IPv4 validate of and then otherwise we return ret. So if we IPv4 validate on S and it's true, then we set ret to IPv4. If we validate on IPv6, then we set ret to IPv6. And that's it. That's all we got to do. As far as that, like, sort of control logic here. And then otherwise we just keep neither. And IPv4 validate, we split on the dots and we say check for leading zeros. We say if, so validate each section of the protocol or the format one by one. So Boolean check true. Actually, return true, otherwise return false. Right. Terminate early here. Whoa. For const standard string reference, I don't know, we'll call it, I don't want to call it S. I guess we could call it S of S, S of parsed. I think that'll make things confusing though. Let's use a different, just call it X, it's fine. I have a different variable, all right. So check for leading zeros. If x.size is, x.size is greater than 1 and x is 0 equals 0, then return false. So we failed the leading zero portion. Ensure that the section is numeric. If x of Boolean check equals true, well, we don't have to do that. We can just say const character C of x if C is 0 less than or equal to C and C is less than or equal to 9. If not, basically, that's not true, return false. So it has to be numeric and it has to be between 0 and 255. Yeah. numeric and less than between 0 and 255 inclusive. So int val equals 0. Say val plus equals c minus 0. We're actually going to multiply by val by 10 and then add this amount, this character, as we add each yeah. So yeah, as we check each digit, we're gonna calculate our value. So our value is greater than 255. Now it's necessarily less than 255 and at least 0, because it's only characters 0 through 9, no leading digits, and there's no negative values. So the smallest value would have to be 0. Yeah. So now we have it's between 0 and 255 inclusive. There are no leading zeros. It's a valid number, or it's all numeric. I think that's it for IPv4. That's all we have to check. And then Ip6 validation is very similar. We're going to parse on the semicolons, check for leading zeros. So the length has got to be between 1 and 4, right? So check the length. Length is between 1 and 4 inclusive. Include size, inclusive. So if x dot size is, say not, say 1 is greater than or equal to x dot size, and see, that's actually not true. Like I said, you can have IPv6 that doesn't have one character in it. It can be, you can actually collapse IPv6. But for now, we'll indulge this, or humor them here. All right, if that's not true, return false. Check the length between 1 and 4 inclusive. It's a hexadecimal string. Could be A to F, 0 through 9, A to F. So surely it's hexadecimal, is this part. We actually don't care what the value is. Yeah, so let's check that next. Leading zeros are allowed in X1, okay. So we don't check for leading zeros here. In which case we don't actually need to copy paste this either. We don't need to check the value is numeric or hexadecimal. Hexadecimal hex characters can be upper or lowercase. Okay. All right. Gonna just remove some white space here. Not sure if we really need all that white space. Righty. So if it's not one of these, and it's not one of these, and it's not, put this in different pieces here, or different lines. And it's not one of these, then we're looking at something that's fails validation. So, all right. So that gives us our IPv6, our IPv4, and that's it. We're done. How did we do? 25 minutes, compilation errors. Nice. Variable declaration and condition must have an initializer. Oh. For, not if. Yep, excuse me. Did that wrong. No matching function for call. Thank you. Okay. Looks like we're in good shape here. Let's see. I need more test cases. Alright, we did okay on these ones. Oh man, this is gonna be hard. So 1/4 of these got accepted. A lot of downvotes. Oh, oh boy. Alright, what are some? We gotta think of some test cases. 1, 2, 3. 0, 1, 2, 1, 3. 1, colon, dot, colon, 1. 300, 300, 300, 300. Oh, I made a mistake. You know, I missed. How many? There's got to be of each piece. I missed that. I would have lost. I would have lost the game. Ensure the correct number of sections. If parsed dot size is not equal to 1, 2, 3, 4, which is 4, are 4 parsed sections exactly, turn false. Same thing here. 8 parsed sections. I missed that before. Ooh, we're wrong. Uh-oh. Uh-oh. Which ones are we wrong on now? This one. 1, 2, 3, 4. The fourth one. Alrighty. 1, 2, 3, 4. This one. Really? Now this is a valid input, right? Just a bunch of dots. So I got IPv4, but this is neither. There you go. Because the string size got to be at least 1. Should not be IPv4. Oh, I can see how you get tripped up on this one, man. This is a hard one. Check for leading zeros. Check at these strings. Sections are non-empty. The section is non-empty. X dot empty. Turn false. I think you gotta do the same thing on the other side too. Oh no, we already did that. Yeah, we did it over here. That it's not empty. Between 1 and 4 implies it's not empty. Okay. Can we just take some gibberish, you know? Oops. letters and characters, and we can do A, B, C, D, E, F, G, E, E, D, F, 1, 2, 3, 4, 5, 6, 7, 8, 8, 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, and then the eighth one. All right, what does this give us? All right, there are a lot of possibilities here for these test cases. A lot that it can go wrong here. 1, 2, 3, 4, 5, 6, 7. Yeah. I think it's 7 here, right? Right. Let's say we could do zeros all the way across. 1, 2, 3, 4, 5, 6, 7, 8. How about that? All right, let's go for it. It's so likely that we miss something. There's such huge likelihood that we miss something. I think we're gonna go for it though. There's a lot of different test cases out there. Oh man! Ooh, integer overflow error. Wow. I'm gonna like this one. I know nobody likes it, but I'm gonna give that a like. Ooh. Who'd have guessed that one? Could you imagine that? Integer overflow. I would never have guessed that. Whoa. Okay. Ah. How big is the I didn't think about how big the input would be. Constraints. Those are the only constraints, so it could be gigantic. Oh man. Talk about a oh man, talk about a test case. Whew. Whew. Wow. So that, I didn't think about that. I didn't think about that. Actually, for my IPv6, this would get validated correctly, but for my IPv4, it would not. Alright, what else did we miss? What else did we miss? Runtime error. Wait, what? Oh. If it's not, then return false. Okay. Alright, what else did we miss? What else did we miss? There's gotta be something else. Oh! That was the only one! Oh, we were so close. We were so close. We were so close. Oh man. We were so close. I did that correctly on the did that correctly on the V6, but I didn't do it correctly on the V4. Yeah, which you can get runtime errors actually. That was clever, man. Whoever wrote this, they did a good job. I like this one. This is a good one. This is a solid question to ask. Man, I missed a bunch. Yeah, there's a lot of pieces to it. A lot of pieces to it. I missed a bunch running a few test cases. I don't know if I would ask this in an interview though. It's like super hard to get it right first time. I don't want to say it's impossible. It's definitely really hard. Yeah, it was. Oh man. Like I said, not hard from a theoretical perspective in terms of like thinking about how to do it, but making sure you get all those different edge cases is definitely really challenging. Super challenging. Wow. Wow. Imagine that. Imagine that. Man, that's cool. That's cool. Also, maybe I should turn down the volume a little bit. I don't know. I think it's okay. Yeah, I guess I kind of like raise my voice every now and then. I kind of tend to talk kind of low, so I guess it's in the right spot. I generally don't talk that loudly. Yeah, man. Well, we got there, but we stumbled. I thought it was gonna happen. No, you got to be like so careful to get on the first shot. I didn't even think that to overflow it. Oh man, that's such a subtle thing. Can you believe it? Can you believe it? We were so close. I didn't think that we were gonna get that the first shot. Definitely not. It's super unlikely. Uh-huh. If you put a comment between every piece of code, you could probably just get rid of the white space. Uh-huh. Can you believe it? Can you believe it? Can you believe it? The IPv6 validation's not too bad. But the IPv4 validation, yeah, it's easy to miss something. No leading zeros. Make sure they're not empty, but they have at most 3 characters. Check that all those characters are digits, and then also get the value. Check the value. Oh man. Yeah, very interesting. Okay, alright, fair enough. Fair enough. So, thank you for watching. Talk to you soon. Have a good rest of your day. That'll be it for me. Yeah, that'll be it for me. I don't know what I'm doing next. I may or may not pick up another problem. Keep going. Who knows? But yeah, this is a good one. This is a good one. This is super interesting. All right, take care.